Hello, everyone. This is Groups 1 Zoom introduction. My name is Salman. I'm a senior ITI student and I'm sub-planning and security. I enjoy soccer, basketball, and football.
My name is Colin Ngoli. I'm a senior ITI student with the security subtract. I currently work as a system administrator and I'm in the Army National Guard. I love to play video games and history.
My name is Ram Perez. I'm in my second half of my junior year. I got out of the Marine Corps in 2020, and where I was a mechanic and later regimental training NCO. Currently, I'm a trio advisor, and I enjoy video games and horror movies.
I'm a senior in the ITI program. I am interning at Daikin Applied Americas as a tier two support personnel. Outside of school and work, I enjoy going to the gym, working in my car, reading, hanging out with friends, and finding a delicate work-life balance.
My name is Chi, and I'm a senior ITI student in the cybersecurity track. I'm interning at a small company called BlueNet. I enjoy crocheting, playing ukulele, and going to the gym.
All right, for three major takeaways, our first one is physical layer technologies. Our second one is IP addressing and subnetting. And the third one is TCP IP model and protocols.
So for the first one here, the major takeaway, the physical layer technologies, I learned the proper EIA/TIA E68A crimping sequence. I didn't know that before. Now I do with the class. I gained knowledge of the different Ethernet cable categories and the various differences between them. I realized how complex Ethernet really is in order for it to be reliable and function day-to-day use. I now understand how electromagnetic interference decides the choice of cables, like fiber, for example, is not there's no issue with it being next to electromagnetic interference because that doesn't happen. So fiber is the optimal choice. And then outside of that, I also learned the difference between fiber, Ethernet, and coax.
Our second major takeaway is focused on IP addresses and subnetting. We learned that every device on the network needs a unique IP address, similar to like a digital street address, so data knows exactly where to go. We also came to understand how subnet masks divide large networks into smaller and more manageable parts. If you look at the image that I attached to the slide, it shows how a /26 subnet mask works using the 192.0.2.0 network. With a /26, we have 64 total addresses per subnet, but only 62 are usable because the first is reserved as a network address and the last is reserved as a broadcast address. This table also makes this clear that the first subnet, 192.0.20/26, with a usable address from 1 to 62 and a broadcast at 63. And the next subnet starts at 192.0.2.64/26 with usable addresses from 65 to 126 and a broadcast at 127. And this pattern continues with 128 to 192. This visualization helps explain how subnetting breaks into one large block of addresses into smaller, efficient networks. It also showed us why subnetting is so important for conserving IP addresses, organizing traffic, and making routing easier to manage.
And the third major takeaway for our group was learning about the TCP IP, that stands for Transmission Control Protocol, Internet Protocol model, and the protocols that make the Internet possible. We came to understand how each layer plays a specific role. For example, the TCP ensures that data actually arrives in order and without errors, while IP handles the addressing and routing the packets to the right destination. And on top of that, we learned that about how everyday protocols like HTTP is for web browsing, FTP is for file transfers, and DNS is for translating domain names. What stood out to me is how the design makes troubleshooting and managing networks easier because you can isolate issues at the specific layer of the layer, and instead of looking at the whole system.
So in conclusion, this learning experience gave us a really comprehensive understanding of network functions from the physical layer to the application layer. And we gained a deeper appreciation for the precision and complexity required to build reliable Ethernet connections. A lot of what we learned from the outside seems really complicated, but as we get into it and delve into it more, we see that a lot of it is kind of in a structure. Everything's very structured, right? There's a right way to do things, there's a wrong way to do things. Nothing's really left up to creativity. And by learning those space structures, it's easy to grow from there. So we also understood the effects of electromagnetic interference and the difference between fiber, Ethernet, and coaxial cables, which also strengthens our grasp of network design performance. So I think this experience and all the things we've learned so far has taught us that networking is more than just wires and codes. It's actually an invisible framework connecting people with ideas and opportunities around the world.